Okay, now I don't really find mixture problems of this type all that difficult anymore, although I do find that I've got to think a little more carefully about them than others. But I do remember when I was first learning algebra, boy, these things drove me nuts. So if they drive you nuts, that's you and my former self, both. I'll probably prove the point by making a mistake on this one. Okay, now, you have two bags. Bag 1 has 5 pounds of nuts, and 35% of the nuts in that bag are peanuts. That's 35% of the weight, let's say, is peanuts. And the bag 2 is 20% peanuts, and we're going to say bag 2 is as big as it needs to be. Because what we're going to do is we're going to add peanuts from bag 2 to bag 1 until we have a 25% mixture. That is, the weight of bag 1 plus whatever we add from bag 2 will be 25% peanuts. You might solve that problem before I do. See if you can make any headway on it. Well, let's see if we can straighten out the camera just a little more. Kind of resistant to straightening out here. Okay. What can we do here? These problems, again, tend to be hard for people. What we need to do is we need to start writing down our information. Any information that we can infer. The very first thing is we see that bag 1 contains 35% peanuts and it weighs 5 pounds. What could we determine from that? Well, we could determine that the weight of the nuts in bag 1 is 35% of 5 pounds, which I believe is 1.75 pounds. Now that's information that we can infer directly. Okay? Now, is there anything else that we can infer? Well, we don't know how many pounds of nuts there are in the second bag. All we know is we have 20% peanuts there. We're trying to find how many pounds from bag 2 are needed to bring this one down to 25%, but we don't know how much we're going to have in the bag when we do that, so we can't really take 25% of anything. At this point, it would be a good idea to decide what to let x equal. We've got all the obvious information. So let's let x equal number of pounds added from the second bag. What can we do now? If we add x pounds from the second bag, then we can say, well, let's imitate what we did here. Let's say we find the weight of the nuts added from the second bag. What's that weight going to be? We can't write a number, a pure number, because we don't know how many pounds of nuts we're adding from the second bag, except to say that that number is x, right? If we add x pounds from the second bag, how many pounds of nuts are we adding? That's going to be 20% of x, because x is what's in the second bag, and the second bag is 20% peanuts. Of course, we might want to make sure we see all the information there. So that this is how many nuts that we've added from bag 1, how many peanuts, and you know, I should really say bags of peanuts because we're assuming these are bags of nuts, so the whole weight should be peanuts, but let's put the P in front of that to make sure that we understand that this represents the number of peanuts, or the weight of peanuts in the first bag, and this is the weight of peanuts added from the second bag. Okay, so now what do we know? We know that let's see. The final mix is 25% peanuts, right? How could we write a mathematical expression for the weight of peanuts in the final mix? We don't know the weight of the final mix, but we can say that what is an expression for the weight of the final mix? Total weight of everything that's been mixed together. We imagine putting bag 1 into a bucket, and then we add a certain amount of bag 2 into that bucket, and we want to end up with 25% peanuts. What's the weight of our final mix after we've added the nuts from the second bag? Well, we add X pounds, so that the weight of the final mix is going to be 5 pounds plus X, right? Now, if we have 5 pounds plus X in the final mix, and 25% of that is peanuts, we can say that the weight of the peanuts in the final mix is I don't really have enough room to do that. I'm going to cross that out. I'll white that out in a minute to get it out of our sight. But the weight of the peanuts in the final mix is what? 0.25 times the weight of the final mix. Because, oops, I'm sorry. Yeah, that's right. So we're getting 25% of the final mix is peanuts. So that has to be the weight of peanuts in the final mix, which is, suppressing the pounds, understanding that all these quantities are going to be in pounds, that's 0.25 times the total weight, which is 5 plus X. Now, where does this leave us? At this point, we know that we have 1.75 pounds of nuts, peanuts, and 0.20x pounds of peanuts in the final mix. Doesn't that tell us that the weight of peanuts in the final mix is what? 1.75 plus 0.20x. And now we can see that we have two expressions for the weight of the peanuts in the final mix. And having two expressions for the same quantity, they must be equal to each other. So if we note that this quantity is identical to this quantity, we can say that we have final relationship. 0.25 times 5 plus X equals 1.75 plus 0.20 times X. This equation can be easily solved. To solve the equation, I'm going to first multiply both sides by 100. This isn't really necessary. Decimals are easy enough to add. But I'm going to multiply by 100 just to clear out those decimals because it seems to make people more comfortable. Unnecessary. If you didn't do that, if you solved the problem, didn't do that, and did it by carrying the decimals through, that's fine. That would have worked. But 100 times 0.25 is 25. 100 times 1.75 is 175, and 100 times 0.20 is 20. Now, if we distribute the multiplication of 100 through this equation, we're not going to multiply 100 by the 5 plus X because 100 is just multiplied by this whole thing. And once we've multiplied the 100 by the 25, we're done multiplying 100. Multiplication doesn't distribute over multiplication. You wouldn't say 100 times this times 100 times this. That would be distributing multiplication over multiplication. That doesn't happen. Now at this point we see that we have a simple enough equation, and we can easily solve this equation. And I'm not going to finish the solution. You can finish the solution. Distribute through here. Add the same thing to both sides to get your x's on this side. Add the same thing to both sides to get the numbers on this side, and multiply by the multiplicative inverse of whatever's multiplied by x.